Okay, guys. So today, my dear students, we are going to start with the next part of the energetics. Yesterday, we have done with the lattice enthalpy. Lattice enthalpy मैंने आपको बताया था कि one mole of ionic compound is formed from its oppositely charged gaseous ions. उसके बाद हमने formation की थी. Formation में क्या होता है कि one mole of a compound is formed from its constituent elements. और तीसरा हमने एटमाइजेशन किया था कि वन मोल ऑफ गैसियस एटम इज फॉर्म फ्रॉम इट्स एलिमेंट. और नॉन मेटल्स और मेटल्स के बारे में मैंने आपको बताया था कि उनकी जो एटमाइजेशन है वो कैसे कैलकुलेट करते हैं. मेटल्स की क्वेश्चन में गिवन होगी, जबकि नॉन मेटल्स की बॉन्ड एनर्जी का बॉन्ड एनर्जी से निकालते हैं. ठीक है. अगली चीज जो हम करने जा रहे हैं माय डियर, दैट इज द आयोनाइजेशन एनर्जी. ये आप लोगों ने A1 में पढ़ी हुई है. आयोनाइजेशन एनर्जी. आयोनाइजेशन एनर्जी जो है दिस इज एंडोथर्मिक. ये हमेशा एंडोथर्मिक होती है. इसकी वैल्यू पॉजिटिव होती है. ठीक है. क्योंकि किसी भी एटम के वैलेंस शेल से इलेक्ट्रॉन को निकालने के लिए हमें उसको एनर्जी देनी पड़ती है, जिसको हम लोग आयोनाइजेशन एनर्जी का नाम देते हैं. ठीक है. सो आयोनाइजेशन एनर्जी क्या होती है, इसको मैं जल्दी से रिपीट कर रहा हूं. आपके पास सपोज करें कि गैसियस एटम है. ठीक है जी. इसके वैलेंस शेल में से आप लोग क्या करते हैं, इलेक्ट्रॉन को लूज करते हैं. इट लूज इलेक्ट्रॉन. जब ये इलेक्ट्रॉन को लूज करेगा तो व्हाट वुड हैपन, इट वुड बिकम गैसियस पॉजिटिव वन कैटायन. ठीक है जी. तो उस वक्त जो एनर्जी हमें इसको देनी पड़ती है, दैट इज द फर्स्ट आयोनाइजेशन एनर्जी. ठीक है जी. इसी तरीके से ये जो गैसियस पॉजिटिव वन कैटायन बन गया, if you want to remove one more electron from it, it is going to lose one more electron. So what would happen, it would become gaseous plus 2 cation. Okay, so this is called as the second ionization energy. Okay, so this is the normal meaning of it. But if you want to define it technically, so what you are supposed to do, you have to take 1 mole of gaseous atom and 1 mole of electrons are lost from it, and 1 mole of gaseous positive 1 cations they are formed from it, and that is called as the first ionization energy. And what is the second ionization energy? If 1 mole of electrons are lost from 1 mole of gaseous positive 1 cation to form 1 mole of gaseous plus 2 cation, so that is called as the second ionization energy. And just like that, if 1 mole of electrons are lost from here, it would become positive 3 gaseous cation. So that would be the third ionization energy. Okay. So I'm just going to write down the definition of the first ionization energy. The other ionization energies definition, they are almost same, but you only have to change the words from gaseous atom, okay, to gaseous plus 1 cation. That is first. And then for the second one, 1 mole of electrons are lost from 1 mole of gaseous positive 1 cation to form 1 mole of gaseous plus 2 cation. So that would be the second ionization. Okay, so just write down its definition. Its definition is the energy change when 1 mole of electrons are lost from 1 mole of gaseous atoms to form 1 mole of gaseous plus 1 cations is called first ionization energy. Okay. And if you want to define the second one, so you just have to change these words. 1 mole of gaseous atom, at the place of this one, you should write 1 mole of gaseous plus 1 cation, and at the place of this one, 1 mole of gaseous plus 1 cation, here you should write 1 mole of gaseous plus 2 cation, so that would be the second ionization. Okay, did you get it? Okay, now the important thing, whatever I'm telling you, in the recent papers, these type of the questions, they are coming in the paper. So most of the students, they get confused with it. What they do, sometimes they provide me the equation. Let's suppose, if I'm going to ask you, this is Mg gaseous form, and it is going to form Mg plus 3 gaseous form plus 3 electrons. So any one of you could tell me that which ionization energy is this one? Third. Third. It's the third ionization. Yes, what you think? Easy, okay, yeah? It's just a discussion. Fourth. Yes, yeah. What do you think about it, beta? Which ionization energy is this? Yeah.
Third.
Third. And Fatma, beta, what do you think about it?
The third ionization energy.
Okay, guys, first of all, we got 3 moles of electrons. So 3 moles of electron mean it's not the single ionization. It's the sum of 3 ionization. Okay, it is going to start from 0. Okay, and this is plus 3. So it will become 0 to plus 1, first of all. This is the first ionization. Okay, then plus 1 to plus 2. This is the second ionization. And then plus 2 to plus 3. So this is the third ionization. So it means this whole thing, that is the sum of first, second, and third ionization. Did you get it? So if the number of moles of electrons are more, if you got only 1 mole of electron, it means it's a single ionization energy. But if more than 1 mole of electrons are present, it's not a single ionization, it's the sum of different ionization energy, and we can see from here from 0 to plus 1 first, plus 1 to plus 2 second, plus 2 to plus 3, that is third. So it means it's the sum of first, second, and third ionization. Okay, so sometimes what he do in the paper, he's gonna give you the enthalpy change of this whole reaction. Okay. No, we will do it later on. Just a minute. Let me explain you with some more examples. Okay, guys, let me do it for you. So this is aluminium plus 2 gaseous form plus 2 mole of electrons. So any one of you could tell me that which ionization energy is this one? Sum of 2 ionization. Which one?
The first and second.
First and second. Okay, that's fine. You are going to say it's the sum of first plus second ionization energy. But I'm still saying it's little bit wrong. Why? Because for ionization energy, you should have the gaseous atoms. But here we got the solid. So it means, first of all, we should change this solid into gaseous form. And yesterday I told you, if any metal or non-metal is present and you change it in 1 mole of gaseous atom, so this is called as the delta H of atomization. This is atomization, and then this one will change into Al plus 1. This is the first, and then this one, that is the second. So it means it's the sum of this thing is okay, but with that you should add delta H of atomization. So this is, my dear, the sum of atomization. First of all, this solid to change into gaseous form. This is atomization. And then this gaseous thing have first and second ionization. Fatma, did you get it, beta?
सर तो अगर कोई suppose
Yes, sir.
इंग्लिश वाला था पेपर निकला तो पेपर में ये आंसर होगा कि सेकंड आयनाइजेशन एनर्जी है ये कंप्लीट ये जो आपने बॉक्स में है ये आंसर होगा
सर ये इन तीनों का सम है बता तो रहा हूं दिस इज वेरी सिंपल इट्स अ सम ऑफ ऑल ऑफ दीस थ्री आयोनाइजेशन एनर्जी अभी मैं इसका क्वेश्चन करवाता हूं डोंट यू वरी अबाउट इट फर्स्ट ऑफ ऑल यू पीपल शुड नो ये है क्या देन वी विल डू इट ओके माय डियर स्टूडेंट्स नाउ I'm going to write one more thing for you and please this time don't do any mistake and tell me. Let's suppose you got iron solid. It would change into iron plus one gaseous form and electrons. So any one of you could tell me which.
So it is the sum of delta H of atomization and the first ionization.
Thank you so much. Beta, this is the solid thing. First of all, you should change it into gaseous thing. So this is delta H of atomization. And then this is from 0 to plus 1. So this is the first ionization energy. So it means it's the sum of delta H of atomization plus first ionization energy. Did you get it?
Yes, sir.
Okay, guys, I have to rub this one. If you have completed it, can I rub this one?
Yes, sir.
Okay, my dear, now we are going to start with some of the questions up here, which are present in the recent papers, and most of the students they get confused. Okay, let's pose. We are going to take this one aluminium solid to aluminium plus 3 gaseous form and 3 moles of electron, and the enthalpy change for this reaction that is positive 480. Okay. Now I want to ask you calculate the delta H of atomization. Delta H of atomization of aluminium. Okay, so this thing you have to calculate. The ionization energy, first ionization energy, its value is plus 400. Second ionization energy, that is plus 900. And third ionization energy, that is positive 1900. Okay, so I have supposed these values. These are not the real values. I'm telling you, just make you understand the concept. I have taken these values. Okay, now this whole equation. First of all, we have to see what is this solid. Solid means it would change into gas. So this is delta H of atomization. Okay, it's the sum of delta H of atomization first of all. And then you got 3 moles of electron from 0 to plus 3. So it's the sum of first, second, and third ionization energies. Okay, so this whole thing that is equal to plus 480. Plus 480. Now you got the values of the ionization energies up here. Put the values up here. Delta H of atomization plus first is 400. Second is 900, third is 1900, that is equal to plus 480. Just add it up, okay, and then take it from here to here, and whatever the value you will get, that would be the atomization of the aluminium. Okay, so here the atomization of the aluminium would become in negative value. It's not theoretically possible, but I have taken values randomly, so that's why you will get this type of the answer. Okay. You got it?
Yes.
Fatma, yeah, beta? Did you
Yes, sir.
Okay, guys, can I have this one? Guys,
Yes, sir.
so we will do the past paper questions as well. First of all, we have to do the first Born-Haber cycle. After that, we will start the past paper questions. Okay. So let's start with the next energy, that is the electron affinity. Electron affinity. What is the electron affinity? Electron affinity, my dear, it is the reverse opposite of the ionization energy. Okay. So let's suppose, my dear, you got this gaseous atom. This is the gaseous atom. Okay. So now in that case, you are going to give it electron. It is going to gain the electron. Gain electron. So when anything gain electron, it would become gaseous -1 anion. So this is called as the first electron affinity. Okay. First electron affinity. Okay. Now this gaseous -1 anion is going to gain one more electron. It gain one more electron. Okay. So what would happen? It would become gaseous -2 anion. So that would be the second electron affinity. And just like that, if this one gain one more electron, it would become third electron affinity. Okay, and the definition is same as the ionization energy. So definition of the first one I'm going to write up here. The energy change when one mole of electrons are gained by one mole of gaseous atoms to form one mole of gaseous -1 anions is called first electron affinity. And if you want to write down the definition of the second electron affinity, then you try for it. Second electron affinity. The same wording.
Sir, the energy when one mole of electrons are gained by one mole of gaseous -1 anion to form one mole of gaseous -2 anion is called second electron affinity.
Perfect, my dear. Perfect. So you only have to change this gaseous atom. At the place of this one, you should write gaseous -1 anion, and gaseous -1 anion. At the place of this one, you should write gaseous -2 anion. Okay, my dear, everybody stop writing and just listen one thing. Everybody. I started this electron affinity, but I did not tell you about it, whether it is exothermic or endothermic. Okay, so this is very interesting. The first electron affinity, that is always exothermic, having the negative value. Okay, whereas all the other second, third, and so on, all electron affinities, they all are endothermic, having the positive value. Okay, so this is very interesting. The first electron affinity is exothermic, while all the other they are endothermic. What is the reason behind it? Everybody stop writing and just listen to me. If you look up here, electron got, beta, just electron got negative charge on it. Okay, so this thing is neutral. It has less valence shell electron. It wants to stabilize itself. So when it gains this electron, it will become stable, gaseous -1 anion that is formed. So this one that is exothermic. It's exothermic. Okay. But now this electron that is negatively charged, and this thing is also negative now. Negative and negative, they would repel each other. Okay, they would repel each other. If the two negative ions come closer, negative things come closer, so they would repel each other, my dear. So if you want to take this electron into this gaseous -1 anion, you have to put the force, you have to provide the energy. So that is why it would be endothermic. Okay, so this is endothermic. In all the other ionized electron affinities like third, fourth, fifth, negative ion is present. And the electrons, they are also negatively charged. So negative and negative, they got the repulsive forces. So in order to take that electron into the valence shell of that particular negative ion, you have to provide the energy. So that is why it is endo. Is it clear, my dear? Fatma, Yahya?
Yes, sir. Yes.
Yes, sir.
Okay, my dear, now if you look up here, let's suppose we got the sulfur. It's a solid. Okay, sulfur normally exists in S8 form. Okay, so here I'm going to write 1/8. This is solid. So it will get 2 electrons and it is going to form S-2 gaseous form. So any one of you could tell me that which energies are this one. First of all, this is a solid, so we should change it into sulfur gaseous form. So this is the delta H of atomization. Okay, and then it would S-1 gaseous form. So this is the first electron affinity. Okay, and then S-1 to S-2, that is the second electron affinity. So it means this whole equation, that is the sum of delta H of atomization plus first electron affinity plus second electron affinity. Okay? Did you get it?
तो वहाँ पर नेगेटिव साइन है सकता
कहाँ पे?
यहाँ पर 5 सेकंड में
वो ऑटोमेटिकली उसकी वैल्यू नेगेटिव होगी तो वो ऑटोमेटिकली नेगेटिव हो जाएगा। तो मैं खुद से लगा दूं, क्योंकि अगर तुम खुद नेगेटिव लगा दोगे तो भाई इसकी वैल्यू नेगेटिव होती है, तो वो नेगेटिव और नेगेटिव मिलके पॉजिटिव हो जाएगा। इसकी वैल्यू नेगेटिव होती है, ऑटोमेटिकली जब यहाँ पे नेगेटिव आएगा तो इट विल बिकम नेगेटिव। डिड यू गेट इट? Okay, my dear, paper में the questions have come. He has given you the energy change for it. Let's suppose the enthalpy change for this reaction is -2780. Not 2780, plus 2780. Okay, and the values of electron affinity he has given you like that. Yani sulfur gaseous form plus electron is going to form sulfur -1 gaseous form, and its energy change that is -460, and then S-1 gaseous form plus electron is going to form S-2 gaseous form. This is plus 1100. Okay, so if you look up here, this is going to gain electron. So this is the first electron affinity. Okay, and this is a -1 ion to -2 ion. So this is the second electron affinity. Okay, so you people have to find out the delta H of atomization. You have to calculate this one. Okay, so what should you do? So this is the sum of all of these values. So this whole values that is equal to plus 2780. Okay, so you got the first electron affinity value. What is that? Minus 460. Okay, this is delta H of atomization. And then second electron affinity is plus 1100. That is equal to plus 2780. Just calculate this one, and whatever the answer you got, put it up here. So you will get the delta H of atomization. Did you get it? So these tricky questions, they are coming in the papers. So I'm going to share a screen with you, and we will do some past paper questions relating to it. Okay. So you people should note it down first of all.
Sir, can you explain it again?
Beta, if you look up here, this is the first electron affinity value. This is the second electron affinity value. This whole equation, that is the sum of delta H of atomization plus first electron affinity plus second electron affinity. So these whole things, they are equal to this enthalpy change. Okay, the first and second electron affinities are given up here. So you put the values up here, just calculate it and take it on the other side, you will get the delta H of atomization. You got
Okay,
it?
thank you, sir. Yes, sir.
Okay,
Okay.
now we are going to do some past paper questions. Okay, मैं यहाँ पे जरा खुद से एंटर हो जाऊं, फिर मैं आप लोगों को आवाज देता हूँ, आपको गा के आता हूँ. Just give me a moment. Yeah, did you get it?
Yes, sir.
Okay, guys, if you can come close together, I will really appreciate it. मैं यहाँ पे screen share कर रहा हूँ, and then we are going to do the questions.
तो डेफिनेटली कनेक्ट होगा इसका।
हो जाता है प्रोडक्ट नेट, लेकिन वो अभी थोड़े बच्चे हैं तो यार जरूरत नहीं है, आगे करो, नजर नहीं आ रहा.
हाँ नहीं दिख रहा।
तो इसको छोड़ दो. Okay, my dear students, this is the data. So you people are supposed to do the part A and B. Come on, part A and B, just do it. आप लोग एक बार try करें, then I will tell you how to solve it. Come on, part A and B. Okay. I think it's better to help you a little bit. First of all, what the question is asking in A, write an equation for the process corresponding to the second electron affinity of sulfur. So second electron affinity means sulfur is already present in the -1 gaseous form. Okay, so it will gain one more electron to form S-2 gaseous form. So this is -2. Okay, so this is called as the second electron affinity. Did you get it? Okay, now in the next question, he's saying sulfur exists as S8 molecules in the solid state. Use the data in this equation to calculate the enthalpy change for the reaction S8 to 8S. Okay, so this is actually the atomization thing. Yani, if you see solid to gaseous form, so here it is written gaseous form. So you should change it into the gaseous form. Okay, so if you look up here, sulfur solid to sulfur gas. So this is actually the atomization. So now what we are supposed to do, my dear, if you look up here, this equation is given. So if you look at this equation, so this equation shows sulfur solid. So solid would change into sulfur gas. So this is the delta H of atomization. And then this sulfur will change into sulfur -1 gas. So this is the first electron affinity. Okay. And then this one change into sulfur -2. So this is the second electron affinity. So it means this whole equation, that is the sum of delta H of atomization plus first electron affinity plus second electron affinity. Okay, and that is equal to, if you see the enthalpy change for this whole equation, he has given plus 555 plus 555. Okay, now what should you do? The values of the first electron affinity and second electron affinity, he has given you -200. So put -200 up here, and then plus second electron affinity is plus 532, and delta H of atomization, and that is equal to plus 555. कितना आएगा? Overall पूरा solve करके. Okay, so the sulfur की atomization, delta H of atomization of sulfur, so that would be plus 223. But this is not your answer. This is for one sulfur atom. He is asking you about the 8 sulfur atoms. So what should you do? You should multiply plus 223 into 8. So that will give you your answer. Did you get it, Fatma? Did you get it, brother?
Yes, sir.
Zabardast. So I think everyone got it how to do these type of the questions. Okay. So that's it for today, my dear students. So inshallah, tomorrow we will start with the Born-Haber cycles. Okay. And the past paper questions as well. Okay. So that's it for today. If anyone got any confusion, so you could ask me. I'm going to give you one more question. Just take a screenshot of it and you should solve it from the home. Can I run this one?
Yes, sir.
Oh my God. Again, I'm going to share a screen. I'm giving you one question. Just take a screenshot of it and practice it at your home. Okay, whatever the part I'm going to say. Okay, guys, do this C part. C part from your home. Okay. Okay, the next question. Let me see if I find any more question. I don't think so. I'm able to find any because this is the newly type of the added questions in the paper. So that's why I find very little questions about it. So let me see if I find any more. No. So you only have to do this question, whatever I've given you, okay? So that's it for today, my dear. So everybody have a nice time. Take care. Allah Hafiz.
Allah
Yeah,
Hafiz, sir.
guys. Assalamu alaikum.
Walaikum assalam.